Yeah, I think we can start now. It's already learned for. Yes, CAN, Control Area Network. Yeah, it's a very hard topic and it's hard used in the automotive application. Most of the issues, yeah, whichever you are seeing the road on the road, uh, any cars or any auto days, uh, the CAN protocol is used. Topic can the technical discussion about the CAN topic. We should know why we need the session on the CAN. Okay, for example, in a car or in a luxury car, how many ECUs? Yeah, as per the Wikipedia page, in the luxury cars, almost 150 ECUs are used. Yeah, ECUs are nothing like electronic control unit. Uh, yeah, it's based on the electronic devices. Similar way, the luxury cars, the controls are in the electronic side. That electronics is combined with a controller. It's called ECU. ECU is nothing like it has a own processor and it has a intelligence to control the complete system. For example, in the survey of 2016, yeah, in the 2016 itself, the luxury cars are used 150 ECUs. In there is a 80 ECUs were used. Yeah, just think about nowadays. Now we are in 2020. Almost the luxury cars we are using almost 1000 plus ECUs. Just think of 1000 plus ECUs are there in the luxury cars. Okay, there is a if going forward or the if you think about 1918, 1980, the car, so we need complete control over in a single device or a multiple device in the control. That we have a lot of sensors and technologies to control. Like for example, if you are connecting ECU like this, uh, you need data from airbag and anti-lock braking system. It's very difficult. That's the reason the bus system or serial bus system is coming to the picture. If you see here, there is a this is normal the way we are connecting the ECUs in the general. Here there is lot of disadvantages like more material cost and more production time and difficult to maintain. You cannot maintain this system longer way. So there is a technology in 1980s during this time that is called serial bus communication. Even older versions are were there, but in the bus, this is a common bus were used for across all the ECUs. If you want to communicate between different ECUs, you can communicate very much lower compared to really the previous systems. Yeah, this is the main advantage of bus system. It is not a point to point communication. Yeah, uh, CAN is a advanced serial bus protocol. This is communicate between any ECUs with message based ID. Yeah, the technical things for CAN we are seeing on the later slides. Live chat. Maybe if time permits, I can answer the questions in this session only. Otherwise, I can send out a mail. Maybe if you have a huge question and uh, please mention your mail ID as well in the serial bus communication. There is a multiple layers over across the serial bus communication: interaction layer, bus success layer, addressing and master slave interaction, time triggered interaction. Bus success is probabilities under control. Addressing is a sender selective or receiver selective. Data protection is a physically or logical. Synchronization is synchronous and asynchronous. Topology is bus system. ring system, star system, and the physical layer is electrical and optical. Yeah, we'll go through the topic individually. The interaction is okay. The multi-master interaction. Each common bus, if you see here, interaction. The multi-master can interact with any node without permission of other node. The master-slave interaction. The master-slave interaction is nothing like there is a master to control all the slave. Okay, for example, I2C, it's a SPI is a master-slave communication. You have a master that will control all the. This is a bus access is divided into a number of time slots among the nodes. It's like flux ray is a time triggered interaction, and a node have access to the bus only in the its scheduled time slot. It's like there is a time slot within that time only the data. Yeah, even a node can schedule a time slot multiple times. We'll go to the next thing like ECU is connected to each other. There is a maintenance. Even ring topology and star topology is almost similar things, but there is a automotive domain, mainly for the automotive domain. Even though the modern refrigerators, even washing machines, they're using CAN protocols. This is very convenient to control the system. That's the reason. The next one, bus access. Okay, controlled bus access. Controlled bus access. The right to bus access is predetermined before bus access. Okay, this is like you have pre-planned. This will be mm, transfer the data already. The access. Probabilistic bus access is a. It's not a predefined thing, but it whenever there is a real time up, things happen. Like if you are applying brake, you don't know when you. So the brake will be applied on the wheel. That's the real time system. So when it's not a predefined things. Next is addressing. We have a two types of addressing is a sender selective and a receiver selective. Okay, the sender selective is a each node will be assigned to a unique node address. Yeah, it's not like here the nodes are like ECUs or processors. It has a own unique node address. The center needs to be identified based on the node address. Even for the multicasting and broadcasting, you need a special addressing things. The receiver selective. Here, receiver identifier are decide to message based. If you are want to transmit some data, there is a message ID. Based on the message ID, it will be transferred. Okay, synchronization. As of start and stop pulse. Okay, there is a synchronization only during the start and stop pulse. Okay, there is a if you want to send us some data or some packet, there is a packet. The asynchronous achieved the throat with clock frequency. There is a packet with with based on the clock frequency. It will be transferred the synchronous transmission way. Uh, it's like for example, CAN also there is a two lines. CAN protocol has a two lines, CAN low and CAN high. It's a twisted pair wires. Here communication. Yeah, yeah. All of us know there is a communication called. No thing the symmetric transmission is very. The result is okay. Now what are the things we have seen? Just we correlated with CAN protocol. The topology is bus. This is the selective synchronization. There is a synchronous transmission. Physical transmission is a semantic twisted two wire. Yeah, the main thing of CAN protocol session is here. We have an intro, what's the CAN and where it started and these things, characteristics, how CAN frames, protocol wise, how it should be. The next agenda will be the frame formats and frame types. What are the CAN frame formats are available and frame types were there. And next one is filter and message validation. How can you can use the filtering option in the CAN and message validation. How the transceiver is validating the message frames. Then how CAN error handling is handled. The last session is bus synchronization and bit construction. Even though I'm like applications and your question answers if time permits. Yeah, then session CAN history by Robert Bosch in mid of 1980s for automotive applications. That design was coordinator of Dr. P. Venkatesh and Mrs. K. I'm planning to start again the CAN protocol. Okay, CAN history. Yeah, Robert Bosch. You know the company, right? Bosch is the, most of the ECUs. It's a very big network. Most of the OEMs are getting support from Bosch. Yeah, Bosch has developed CAN protocol. It's rolling automotive domain almost 40 years. CAN is a very big thing protocol. Yeah, Bosch is designed for this protocol for reliable of automotive system and safer and more efficient way of fuel. Not only the fuel, even the complete system, the controlling of the system. That's why the CAN is coming to the picture. Okay, what is CAN? It's a control which is more efficiently distribute the data from the diff. Yeah, the next point is CAN is a serial bus system. It's mainly suits for network intelligent devices as well as sensors. Lot of sensors and actuators are there. If you want to get the data from the sensor, that also designed. Some of the sensors are designed by CAN protocols. The data will be transferred from sensors to ECU over CAN. Even for example, whichever I have mentioned, the brake is there is a sensor to sense how much pressure you are applying on the brake. Based on that, the braking system will work. So CAN will assure that it's very less latency time. So CAN will be rolling the automotive industry over 40 years. Even it can roll upcoming years also. Yeah, that's the special of CAN. Okay, how the CAN node will be? Yeah, if you see here, this is the ECU. For example, you just think about this is a ECU. Uh, Even our microcontroller will be looks like this. We have a microcontroller. There is a CAN controller inside the microcontroller. It's a serial protocol, right? So there is in between CAN transceiver and the CAN controller, there is a serial communication called this is CAN TX and CAN RX. Most of the people are hear these things. Uh, I think there is a few questions over there in the live chat. I can go over there and we'll come back again to this. Sorry, guys, just I'll pause here. Should be okay. Safer for fuel efficient. Yeah, CAN protocol is a control area network protocol. It's a serial communication protocol and uh, yeah, it's class C in vehicle network and a very less latency time and it can support up to 1 Mbps baud rate. Sorry, bit rate. And I'm coming to the picture. There is a microcontroller. There is a CAN controller. What is the difference between the microcontroller and CAN controller? There is a CAN transceiver also. If you see the microcontroller is designed to do all the logical operations and every whichever you are coding. For example, you are doing some programming over the microcontroller that will be processed in the controller. Yeah, microcontroller. The only CAN part will get the can transmit the complete data that will be transferred through the CAN TX and RX. It's like a TS, CAN TX is transmit, CAN RX for receive. There is a IC or yeah, this is the twisted pair. There is a two lines. There is a differential voltage over there. Here the data will be transferred. You can prioritize your message. For example, uh, you are running in the car. Always car will be checking on the speed and what's petrol level, these things. But if you are applying the brake, apart from the speed, everything, all the things, the brake is higher priority. So the data should be transferred in the brake system. So The CAN will have the prioritization. CAN has the intelligence to prioritize the message. How the prioritization is working? Priority will be given to the CAN. That will be coming under the next slides. Configuration of flexibility. There is no theoretical limitation of the node. Yeah, CAN is have a two versions like a normal CAN and a extended CAN identifier. CAN identifier has a normal 8-bit and there is a 29-bit CAN, sorry, 11-bit and 29-bit CAN identifiers. This is multi-master broadcast communication. You can broadcast the data throughout all the network. The this has a multi-master. Any node can transmit the data. Even multicast reception with time synchronization. Yeah, multiple nodes can receive same data. That is also possible here. Retention of corrupted message. Okay, if there is a error and the message got corrupted, CAN has the intelligence to retransmit the same message again. There is a difference between the temporary error and permanent failure on the CAN node. That also can handled by CAN. Yeah. Uh, CAN message can transmit 0 to 8 bytes of user information. Yeah, the data parts will be, you can transmit 0 to 8 bytes. Like you can transfer 0 bytes or 8 bytes anyway. That's as per your user. The address based and message based. Address based is each node has a address. Only node to node can communicate, but CAN has a message based communication. In a single node, you can configure multiple messages. That's the specialty of CAN. Yeah, there is a very lower weight. The wiring will be very simple and size and installation cost is very less. How the layered structure of CAN node? Okay, here there is a application layer. Yeah, I think even computer science IT guys were joined in the session. CAN is not only like only electronics background or electric background students or people can study on the CAN. Even IT professions like who are developing the application, they should know the CAN. Then only they can develop the CAN protocol application. Like if you want to design a application like to transmit or receive the CAN channels, sorry, CAN messages and display on the PC, then for that at least some knowledge should be there for the even IT guys to design their application. Yeah, this is the application layer which is in the PC. There you can message status handling. Message filtering is like there is a uh, unwanted message coming to the node. The message filtering will stop the message. There is a intelligent tool, message frame, time, timing, and transfer rate. These things will be handled in the transfer layer. Yeah, finally the physical layer. Yeah, it's this is the real bus layer. Here this is handled the signal level bit representation transmission medium. Okay, coming to the physical layer. Okay, uh, this will this diagram will give you complete clear picture. The node A, node B, node C. There is a three nodes. You can consider there is three ECUs have connected together in a same bus of CAN bus. This is CAN low, CAN high. There is a twisted wire pair wire will be connected in the each node. CAN is a insensitive to electromagnetic interface hits on the bus, both bus lines like CAN high and CAN low will affect in the same way, which leave the differential signal for unaffected. Yeah, now we are seeing this slide in the physical bus layer. We are connected in the same bus, CAN bus, receive and transmit, receive, transmit. CAN has only two logic called dominant and recessive bits. There is a only two logic over there in the CAN. There is a dominant bit and a recessive bit. Dominant bit is like a logical level 0 and recessive bit is logical level 1. Yeah, again I am repeating that dominant bit is logical level 0. If there is a logical level 0, then that is called a dominant bit. There is a logic level 1, that is recursive bit. Okay, for example, there is a truth table for the three nodes C, B. There is a dominant bit. The bus will win only the dominant bit on the bus. Okay, for example, the first case, A transmit dominant bit, B transmit dominant bit, C transmit dominant bit. The bus will contains logic 0. The second case, A transmitting logic 0, B transmitting logic 0, and C, node C, this case, node C logic 0, the bus will be occupied by logic 0 only. If all the bits are recessive bits, then only the logic 1 will be coming to the bus. Okay, bus arbitration. It's the very important concept in the CAN, because initial time there is a no arbitration concept on the other protocol, only during the initial time, not now, initial time. Only CAN has the intelligent 2 has the arbitration mechanism. Yeah, arbitration mechanism is whichever we have seen previously. If you are transmitting the identifier, yeah, what is the SOF identifier RTR? These will be explained in the upcoming slides. This is the frame format. These things are frame formats. This will be explained in the upcoming slides. Here we have a node 1, 2, 3. This is the bus level, the CAN bus. These three nodes and bus. It's start of the frame always same. Transmitting the identifier 1, 1, 1. Bus wins 1. Here all 0. Bus also in 0 position. Here 1, 1. Logic 0. Node 1 and node 3 has logic 0. Node 2 has logic 1. If the bit is transmitted in the CAN transceiver, here there is a logic 1, node 1. Here node 2 has logic 1. If you see, the node 3 has a logic 0. This is dominant bit. The bus will win the dominant bit. Speedometer, this is for engine petrol consumption, and this is for brake. If these things are running, if same time, at the same time, if you are the same time task or high priority message, so the braking has a lower CAN ID, so the braking will win the bus. So the braking data will be, the node 3 data will be transferred on the bus. This is the bus arbitration. I think it's explained. Okay, CAN protocol. Frame formats. We have two frame formats in the CAN protocol. One is standard frame and one is extended frame. Standard frame is 11-bit identifier. The extended frame is 29-bit identifier. Yeah, here the identifier has the individual address and the frame types. We have 4 frame types in the CAN. One is data frame, the next one is remote frame, one is overloaded frame. Yeah, we will see what are these things in the upcoming slides. Control bits, data bits, and CRC, acknowledgement, end of the frame, interframe space. This is the protocol structure for the CAN. What are the internal components over there in the protocol? We'll see. First one is start of identifier. Yeah, already I have mentioned we have a two types of identifiers. One is 11-bit identifiers, one is bits. The 11-bit identifier is B0 to B11. There is 2 bits next to the ID. There is a ID. If you CAN message, it's a 2 power 11 CAN messages you can define. If you are going for extended, then it's 2 power 29. Just imagine how many messages you can design. That's the winning of CAN. Here the data length code. Again, it's a simple thing. It's a 8 byte, right? So 000 means nothing. 0 bytes you are transferring. 1000 means it's you are transferring 1 byte. 1100 is 2 bytes. Yeah, even you know the truth table. Yeah, again 101 is 3 bytes. Similar way, this is the how you are representing or how many data you are transferring in the data section. Transferring some data to the one node to another node. How you are ensuring the data is transferred to the other node properly or not. With some code. That same code will be calculated by the receiver node. Acknowledgement. Okay. Acknowledgement is like if there is a uh, acknowledge sorry active error flag, active error, 7 recessive bits. The continuous 7 bits is coming. If there is a continuous 7 bits coming, then it's a end of the frame. The interframe space. If you are transferring 2 messages, then there is should be some interframe space. One message is transferred, then 3 reges. Okay, many bits for the standard frame and the extended frame. Start of the frame, 11-bit identifier, RTR, and ID R0 is reserved, DLC 0 to 64 bits. It's like 0 to 8 bytes. Yeah, 1 byte is 8 bits, and 15 bits of CRC field, acknowledgement field, end of the frame, interframe space. Uh, there is small where you can see these bit information or these kind of okay canvas high and low. Check on the oscilloscope. In the oscilloscope, you can find these kind of waves. There you can identify what are the frames are transferred to again. This the difference between standard frame and extended frame. You can see and changed. The next one is remote frame. Okay, remote frame has always there is nothing to transfer. Zero data. Data is zero. Yeah, DLC is always zero. It's like to get data from the different node. This is like a request frame. If you want to request data from the other node, the design of the node B also should send the data from to expected frame. This is called remote frame. Yeah, it's already we are on time. Maybe I'll take it 5 to 10 minutes. From there you will get the certification link. Maybe can you please hold on 5 or 10 minutes? I will finish it off quickly. uh, Error frame formats, active error frames. Yeah, this is how the active error frames were there. This is uncompleted frame where you will get 6 bits. uh, there is a error or there is a EMI involved. affected on the bus. These 6 bits will be suffer on the bus. So this this is called synchronization, asynchronization. There is a deviation on the synchronization. That's the reason the error frame format will come. Okay, uh, this is that for this only we are using bit stuffing. CAN has a technology called bit stuffing that will be given to the next flight. Overloaded frame format. Receiver required a delay to receive the next data or remote frame. Okay, there need a delay to receive the next frame, but some other node is some design logic error or bug. It's transmitting data so fast, then there is a overload frame will occur. That also handled by overload delimiter in the CAN protocol. Interframe spacing. Yeah, as I already mentioned, there should be a interframe space, 3 bits, uh, to separate 2 frames. Then only CAN protocol can identify the next frame. Okay, there is a filter concept. For example, uh, if you see in this diagram, multiple nodes were connected. For example, this multiple nodes were connected in the same bus. This is the CAN bus. Multiple nodes were this node transmitting, for example, message ID 5, some ECUs. But because it's connected all together in the same bus, so that data will go all the ECUs. But ECU has the own filters or can control allowed to the node. Yeah, coming to the again back to the slide. Yeah, this is example ABS. This node will send data to all the uh, connected ECU on the bus. There is a mask to receiver. uh, for example, AC will reject the data, the talk data, but ECM will accept the data and process the data. Okay, again the message validation. Yeah, as similar the message filters only. Message will be validated. Transmitter and message validator is there is no error or until the end of the frame. That is called message validation. There is a logic in the CAN transceiver itself, which will be validating each bit. If there is a error or not, nobody is acknowledged or some acknowledged different, then it leads to acknowledged acknowledgement error. Then whenever there is a error passive or error active, CAN will be reinitialized again, then it will go to the active state. Okay, the main concept is bit stuffing. This what we are getting the synchronization on the bus. This is very important concept on the CAN. For example, without bit stuffing, if you are transmitting the data, like there is a dominant bit and continuous, you cannot find how many bits are interacted in the synchronized way. That's to uh, unsynchronize or collapse the synchronization. If you are or the frame format, if there is a 5 continuous bits, or if even it's a dominant bit or even it's a recursive bit, if there is a dominant bit, or here for example here the continuous 5 recursive bit, there is a additional bit. This will be known by CAN transfer. This is a just additional bit. It will not do anything. This is just a bit stuffing, just creating one dominant bit to synchronize the bus always. That's the reason the bit stuffing is coming to the picture. For example, if you see here, the one we are introducing the bit stuffing only to resynchronization of the bus. Uh, Even if you see there is a continuous 6 dominant bit, there is a recursive bit for the bit stuffing to enable the synchronization, the bit stuffing. Yeah, this is a bit stream.